Hello. Today we will be talking about the sliding window uh, uh, approach to solving like algorithmic computer programming problems. Um, so, what the sliding window technique is whenever you have a problem which asks you to find like the longest contiguous um, something, some property of some elements of some array, uh, you can use the sliding window technique to like efficiently solve it, usually in O of n. Um, so first, I will talk a little bit more about what the sliding window algorithm is, and then we'll go ahead and take a look at one sample problem which you can use to solve it. Um, okay, so uh, sliding window technique. Um, as I said, it's whenever you have a problem where you have like it's an array of numbers, uh, and you're looking for like some sort of property between the elements, and you want to find the longest contiguous subarray that contains that property. And the reason why um, uh, we want to emphasize the fact that it's contiguous is because the whole point of the sliding window algorithm is that uh, we want to like we want to construct some window such that every single element within our window all has the same property, and then basically we kind of want to like shift this window to the right um, in some sort of loop, and keep extending the window to make it as large as possible, and find out where we can like place this window to include the most amount of elements that all satisfy this property. And you might notice that like this only works if um, it only works for problems which ask for continuous like a subarray, some sort of sequence of elements that are continuous within the array, because a window is continuous. You can't have breaks in your window, so you can't have anything in the middle of your sliding window algorithm that's just not going to uh, uh, like give a valid solution. um, okay, so now let's talk about the time complexity. Why do we care about the sliding window algorithm? The reason why is because usually for stuff which asks for some like uh, contiguous subarray of an array, for example, um, a brute force way to do it would be that, okay, so what is a subarray defined by? Every subarray is defined by two things. One, the left end, and the right end, right? So one way to do it is to like maybe check every single subarray that you can construct, and then see if that particular subarray like satisfies the given property. So this is n cubed actually, which is just horrible. So uh, the reason why it's n cubed is because um, you have to find two. Uh, there are two things you need. You need the left end of the subarray and the right end of the subarray, and you can have n left end, le approximately n left ends and n right ends. So for every left end, you can have n different right ends. So it's n times n. And then to actually traverse that subarray, you have another n on average. So it's n times n times n, which is n cubed, which is not that good at all. But with the sliding window algorithm, the goal is that in every iteration of our loop, we want to like we want to somehow move one of our ends of the window, right? And we want to do it in such a way that our window always like approaches like termination somehow. So one way we can do it is we can start off our program by having the window pointers be on the opposite ends of the array, and somehow we shrink our window so we always move it in the same direction, inwards, right? Another way, the way that we'll be looking at today, is we have our pointers on maybe one end of the array, and we always move one or both of the pointers to the other end, always in the same direction. So this way, every iteration of the for loop, we have some pointer being moved in the same direction. So that means that there will, at most, there will only be two times the amount of elements in the array, so 2n, which is O of n, uh, amount of iterations. That's the most that this can take. Because if every iteration of the loop we move one of the pointers, then and we are always moving the pointers in the same direction, then there's only 2 times n like things that we can do. So that was a little abstract. So let's go ahead and um, look at a practical application, or I mean, as practical as leak code is. So I guess for a job interview or something. Let's go ahead and look at this. Um, so the problem we'll be looking at today is max consecutive ones 3. So the goal of this problem is basically you have some array of bits, zeros and ones, and you have another parameter k, and the goal is to find um, the maximum subarray. See, the words you should be looking for is consecutive. That's how, kind of like a hint that we should be using sliding window. So you want to find the maximum number of consecutive ones in the array, and you can also flip k up to k zeros into ones to find maybe a larger contiguous subarray. Okay. All right. So here's an example. We got this subarray. They flipped, this bit, because you're only allowed to flip at most 2, and they found out that this is the maximum subarray, and they have to return the length of it. So it's 6. Same with here. Okay, so one solution is to you have a left pointer and a right pointer, and you start them both on one end of the array. And then you have a while loop. And then here you have a variable which you keep track of how many bits you've flipped, just so that like at the beginning when you haven't flipped all your bits yet, you can still like that like you're able to flip a bit with no consequences. Because you might notice that later when you have flipped k bits and then you want to shift your window, in order to flip another bit, you have to unflip the first bit that you flipped. So this is what that's for. So we have a while loop where the while loop terminates when our right side end of the window has reached the end of the array. The reason why we only care about that is because the left end of the thing can be doing whatever it wants, but we don't want to bring the left end any further in, because that would not give us a better solution than what we already had, right? So this is all we care about. Okay, so we have two conditions. One, if the right side end element is 0, or if the right side end element is 1. So if it's 0, then we can do two things. One, we can flip it with no consequences, or we can flip it with a consequence, where we have to bring in our left end of the window all the way past our first flipped bit. And when I say first flipped bit, I don't mean our first flipped bit in the whole operation. I mean our first flip bit that is within our window at the moment. Okay, so the no consequences thing, that's pretty simple. If we haven't even flipped k bits yet, then yeah, sure, just go ahead and flip a bit to 0, flip that bit, and just move on with your life. So extend the window a little bit more, but you also have to keep track of the fact that you just flipped a bit. Okay, so now we're getting to the real portion of the problem where you've already flipped k bits, so now you have to unflip a bit by basically moving your window past that first bit. Okay, so how do you do that? Well, first um, you have to note down how long this window was, and check if it's like update the return value. Then now you can go ahead and shift your pointer further to the right, but you also have to shift your left pointer, and the amount that you shift it by is equal to the um the amount of ones that are between where your left pointer originally is and the first 0 that you encounter, because the first 0 that you encounter means that that's the first bit that you flipped, right? Inside your sliding window. And then if the left pointer reaches the end of the array, you can break. But yeah, and then you can just do one past that first flip bit. So that's what this +1 is for. Okay, so that's all that. And if the bit that you encounter is a 1, then yeah, that's simple. Just go ahead and increase this, and that'll make our window a little larger with no consequences. At the end, you just return the best window that you have. So yeah, hope you guys learned something. That's all I got for today. So please let me into UPE. Thank you very much. Goodbye.